Hello, am I audible? Hello. Type yes if I am audible. Okay, Anurag. Hello, everyone. Am I audible to you guys? Type yes, please. Okay. How many of you have tried the combination of factors problem on my code? Has anyone successfully submitted it? Has anyone successfully submitted it? Okay, okay. We will be discussing that today, okay? Till the implementation. I will show you the implementation also. Okay. Pawan, can you hear me? Hello? Okay, fine. So let's begin. Okay. Can you guys see the screen? Yeah, I will implement. Don't worry. Okay. Have you, is there anyone who doesn't know what this question is? Do I have to explain the question? Type yes if you want me to explain the whole question. Okay, okay. So what it given in the question is, Arnab is given a number n. Help Arnab print all the combination to factorize the number. Print the combinations in lexicographical order. What is the meaning of this? That, for example, the number given to Arnab is 8. The number given to Arnab is 8. Okay, so the factorization of 8 can be 1 into 2 into 2 into 2, or 1 into 2 into 4, or 1 into 8. Okay, so this we have to print in lexicographical order. Fine, first this one, then this one, and then this one. I will give you more examples. Just wait. So for example, the number that is given to Arnab is 12. Okay, so what can be the different factors of 12? What can be the different factors of 12? Okay, so let's begin with that point only. So do not think of recursion. Do not think of recursion. Let's just think of how we can do the factors of 12 thing. Okay. So how you can calculate the factors of 12? Just in the mathematics we do. One can obviously divide any number. So one will be definitely be there. One can divide any number. Okay. 1 into 12 is 12. Then check with 2. 2 into 6 is 12. So 2 is a factor. Okay, fine. Then start with 2 again. 2 into 3 is 12. 2 into 3 is 6. Understood. 3 to 1 is 1. Anyone has doubt in this part, how I'm factorizing? Type yes or no. Come on, guys. So we have 1, 2, 2, and 3 here. Is it okay? Should I move forward? Hello, come on. Should I move forward now? Okay. Now 6 here, I can divide 6 with 3 also, isn't it? Here 2 remains, then 2 comes, and this come 1. So here we have 1, 2, 3, 2. But this is a repeated factor, repeated sequence, because we already have 1 into 2 into 2 into 3. This is the same thing. Is it understood why this is a repeated sequence? We will handle this case, but right now we are moving forward with this. Yes, we will have repeated sequences. Okay. I'm just simply factorizing now, nothing else. After 3, can 4 factor 6? Can 4 divide 6? No. Can 5 divide 6? No. Can 6 divide 6? Yes, 6 can divide 6. So 6 into 1 is 6. So I also have 1 into 2 into 6 as the answer. Is it clear? The 3 sequences that I wrote till now? Type yes or no. And I am only seeing the sequence that are starting with 1, 2 right now. Then I will move on to 1, 3 because we have to do in lexicographical order. Okay. Now 6, I have all seen the factors of 6, that is 2, 3, and 6. Now I can move forward, and now we will go back and see the factors of 12. Except 2, what are the different values that can divide 12? Okay, so let's start with that now. So 1 will definitely do it. Now we have already seen 2. Let's skip 2 now and go to 3. Can 3 divide 12? Yes, 3 can divide 12. So 3 into 4 is 12. And what can I write here now? 4 itself. So 1, 3, and 4 is another sequence that we get. 4 into 3 is 12. 4 into 3 into 1. Okay. If you want to write 2 here, then it will be again 1, 3, 2, and 2. This is the same sequence. Again repeated. 1, 3, 2, 2. Yeah, is these 2 points clear? Come on, type yes or no. Okay. So now anything else that can divide 12? So 1, 12, 12. So after 3, we can go to 4 also. This is the same sequence will be repeated again. That is nothing but 1, 4, 3, the same values. And you can go to 6 also, then 1, 6, 2 will be repeated. I have skipped this part. So have you understood these 2 points? How these 2 will come again? Hello? Okay. So now we have so many sequences, but actually the sequences which are not repeated are 1, 2, 2, 3, 1, 2, 2, 6, 1, 3, 4, and also we will definitely have 1, 12. 1, 12, 12, 12 can divide 12. So we will have 1, 12 also. Okay. So only these sequences, this one, this one, this one, and this one are not repeated. And this one also I think is not there. Only these 4 sequences are not repeated, rest all are repeated sequences. So we just have to print these non-repeated sequences in lexicographical order. Is the question understood by this example? Okay. Now, okay, what do you want me to explain it again, Kumar? This simple mathematics. Okay. Okay. Just tell me. Till where? Till here, have was your internet connected till this point? Hello. Okay. These are just the factors that I am writing. By seeing the screen, can you understand? These are just the divisions that I have written and nothing else. Can you see here? 1, 2, 2, 3 is a factorization. 1, 2, 3, 2 is same, repeated. 1, 2, 6 is unique. 1, 3, 4 is unique. And this is again the same that is repeated. Sorry. 1, 4, 3 is again repeated here. 1, 6, 2 is repeated here. And 1 and 12 is unique. So what are the unique factors that we have? The unique factors that we have are 1, 2, 2, 3, 1, 2, 6, 1, 3, 4, and 1, 12. This is the output. This should be the output according to the question. Is it understood, Anurag, that this should be the output according to the question? Hello. Yes, I will explain that, Prabhat, but I have to go step by step. Okay, okay, fine. Now, I think you guys can think of a for loop approach, an iterative approach for this question, because I will be explaining the recursive approach here. So, for example, we have a 12, and 1 will definitely be there. Okay, fine. We'll begin with 2. We'll begin with 2. 2 can divide 6, correct? 2 into 6 is 12. Now again begin with 2. 2 into 3 is 6 and 3 into 1. Now here you have to actually check with 2 again. First we check with 2. 2 cannot divide it. So check with 3. 3 can divide? Yes. So begin with 1. So one of the factor is 1, 2, 2 and 3. Now when I wrote the second one, haven't I repeated the previous 2 steps again till here? Isn't it the same step that I did previously? 1 divide 12, 2 divides 2 divide 12 by 6. Come on, isn't it the same steps? Correct? The same, these steps till here. These are same, correct? Is this point understood that these are same? So instead of doing them again, I can just come back here using recursion. I can just come back to this place. I can just come back to this place here. Have you understood what I'm saying? The logic behind it. Instead of repeating it, I can just come back to this place. Come on, guys, you are not replying. Should I move forward? I will just move forward without asking if you do not reply to me. Okay. So here, we will come back here. Now we have already checked with 2. Now we have already checked with 2. So do not check with 2 again. We will just simply increment it. So we will check with 3. Okay. Now 3 can easily divide it. 3 can easily divide it with the help of 2. Now you here to stop this, to stop the what you say the repetition, what restriction can we put here is, what restriction we have to put here is, you cannot begin again with a smaller number. We cannot begin again with a smaller number. The reason being, if it was divisible by 2, then we have already handled that case. If this is divisible by 2 before 3, that means we have already handled that case. You do not have to handle this case again. If 2 has should have divided 6, that means that case is previously handled. You do not have to handle this case again. Now this is an important point here. Now I am repeating this point again. Here 2, we have already handled the case when 2 divides 6. When 2 divides 6. Okay. Now 3 divides 6 in the terms of 2. That means 2 into 3 is 6. 2 into 3 is 6. 3 into 2 is 6. Correct? Now this case is actually already handled previously. This case is already handled previously. These and these are same. These and these are same. This case is already handled previously. Okay. You do not have to handle this case again here. Fine. So once we put a restriction that you cannot put a smaller number again here, so you have to check with actually 4 or 3. Begin with the same number 3. 3 cannot divide it. Change to 4. 4 cannot divide it. Change to 5. No. 6. No. 7. No. Till 12. Okay. No number can divide it. Since we do not get a 1, that means it was not a perfect division, and this values will not be printed. These values will not be printed. I will explain this point again because this point is important. Fine. So what we are simply doing here is when we go back here, so it is nothing but 1, 12, 12, 2, 6. Correct? Now two case we have seen, 2 case we have handled. Okay, the next case is 3. Now 3 divides 6 by 2. This is true. Now if we put a restriction here, that do not again begin with 2. Why we put a restriction here that do not begin again with 2? Because this case, that is 3 into 2 equals to 6, is already handled here. 3 into 2 equals to 6. In multiplication, you write 2 into 3 or 3 into 2 is exactly one and the same. Am I correct? So this case was already handled previously. If a smaller number can divide this number, that means we have handled that case previously. We have incremented from that smaller number. If 2 can divide 6, this means we have already handled that case. You do not have to use the 2 again. Okay, all the factors if for 2 divisible by 6 is handled previously only. After handling them, we came to this step. Is this understood? Here also 2 into 3 was 6. Here also 3 into 2 is 6. Now 2 into 3 is exactly equal to 3 into 2. Okay. Now we put a restriction that if values come, you cannot begin with a smaller value. You have to begin with the same value. Okay. Can 3 divide 2? No. Go to 4. Can 4 divide 2? No. Go to 5. Till how much? Till 12. No value can divide this. We will never get a 1. Since we never get a 1, these factors will never be printed. Okay. Now this simple case will handle the repetitions. Okay. Now the important point is commutative property, that A into B is equal to B into A. These 2 points are same. If I handle the A case here, that means this case was already handled. Okay. Yes, that is what we will do, Prabhat. I will just, you can verify it in the later part of the video. Okay, in the session. Now I am explaining step by step. Is this point clear? Okay, now let's move forward. Okay, till what we have come? Yes. Now we have handled 3 cases here. 3 is over. Fine. So no value can divide 2 here. We will come back to this position. Okay, and 3 will be incremented to 4. Now where we are, just see this point where we are. 1, 12, 2, 6. Now see, we have seen the case when we divide 6 with 3. We have seen the case where we divide 6 with 2. Okay, that means this case is over and this case is over. Now we will move on to this case. Okay, This case we have seen, this table we have seen. Now we move on to this table. That means 3 will be incremented to 4, but 4 cannot divide 6. Then it will be incremented to 5, but 5 cannot divide 6. Then it will be incremented to 6. Can 6 divide 6? Yes, 6 can divide 6. So we'll come to as 1. As soon as you get 1, 1 to 6 will be printed. 1 to 6 will be printed. This is unique. This is completely unique. Okay. And when you go back and increment it to 7, just see that this number becomes greater than this number. That means you have to stop. You have to stop and go to the previous step. You have to stop and go to the previous step. That is nothing but here. That means we have all exhausted all the cases for the value 6. We have exhausted all the cases for the value 6 when this number becomes more than the number we are dividing it with. Now, is this clear? Because this is exactly the recursion. Let me just draw these points again. Now we have seen 2 case with 6, it's over. We have seen 3 can divide 6, this case is also over. We have seen 6 can divide 6, this case is also over. That means the first 3 cases, this one, and this one is now complete. Okay. Now we have to move to the case where this is completely over. Now this is completely over. Now go to previous and see, is there any other number about 2 that can divide 12? Is there any other number about 2 that can divide 12? So yes, we definitely have those. Okay. So here it is 12, here it is 1. So here it is 12. So now tell me. So 2 is over, 2 cases over. We have seen all the possible combinations with 2. Now let's move on to the next number 3. Can 3 divide 12? Yes, 3 can divide 12 by 4. Okay. Now we have put a restriction that you cannot start with a smaller number. You either have to start with the same number or a bigger number. Okay. Now since we have put that restriction, this 1, 3, 2, 2 case will not come. This repetition is handled. Okay. You begin with 3. 3 cannot divide 4. No problem. Go to 4. Can 4 divide 4? Yes, by 1. As soon as you get 1, print 1, 3, and 4. Okay. Now I think you should be able to get till now what we are doing. What are the steps? Now 4 is over. Fine. As soon as you increment it again to 5, 5 will become greater than 4. Go to the previous step. Go to the previous step. As soon as this number greater than this, go to the previous step. Let's see the previous one. 1, 12. Now 2 case we have seen completely. 3 case we have seen completely. Can 4 divide 12? Yes, 4 can divide 12 by 3. Now this restriction will again come into handy because you cannot start with the smaller numbers. You have to start with 4. Okay. As soon as you get 4 here and 3 comes here, that means this number is greater than this number. Then you just have to simply stop and return back. Now increment it to 5. 5 cannot divide it. Increment it to 6. Now again this condition will come into handy. Why? 1, 12, 6. 6 divide 12 by 2. Okay. Now smaller number cannot come here. It will start with the same number. 6 is greater than 2. That means you just have to stop and return back. Okay. And now it will become 7. 7 cannot divide 12. 8. 8 cannot divide 12. 9 cannot divide 12. 10 cannot divide 12. 11 cannot divide 12. 12 can divide 12. So 12 into 12 will become 1. 12, 1. 12, 12, and 1. So this will be printed. That is 1, 12. Now as you can see, only those numbers are printed that were unique. By having one condition, by observing that using one condition, we can take many things away. We can just reduce our repetitions. I think one of you was having problem with the repetition part of the code. I think these 4 are the answers and these 4 will be printed. Okay. So now this was about the repetition. That's your choice. I will be storing it in string because printing string is very easy. Printing an array takes another loop, but printing a string does not take anything. Okay, so I will be storing these numbers in a string. Fine. Okay, let's now move forward. So this is exactly actually the recursion that we are going to do. Exactly this is the recursion. Exactly this. How? Let's see now. We have our number. We have our number. That is nothing but 12. Okay. We have a string and start that string with 1 and a space. Start the string with 1 and a space. Why a 1? Because 1 will definitely be there. 1 will definitely be there. Okay. Why space? Because you have to print it like this: 1 space, 2 space, 2 space, 3. Okay, 1 space, 2 space, 6. So therefore a space. Fine. Let's begin with this point. Okay. Now we also have one more element. Now why this element is there? This variable will help us track the repetition. That means you cannot use a smaller number for that part. You cannot use a smaller number for division again for that part. You need a flag, you need a variable that will tell them you are using a smaller number or you should begin with only that number. So for example, which one should I show to you? Like this here, 4 was there, correct? Now 4 is smaller than 3. Not this one. Let me see. Yes. Which should I show? Okay, here only. Now 3. 4 was here, 3 was here, 3 was here. Where it's gone? There were so many examples right now. Okay. See this here. 12, 3. 3 can divide 4. Okay, fine. Now you cannot begin with 2. You should begin with 3. So what we will do, we will pass this number in our variable. We will pass this number that you should always begin with the previous number. We should always begin with the previous number. You should not begin with a new number. That is a smaller number. Okay. So you should not begin with 2 again, or you should not begin with a smaller number again. You should always begin with the number that was used in the previous division. Okay, begin with that only, begin with that number, not a smaller number. So that is why it is used. Okay, now starting position of p will be, can you guys tell what will be the starting position of p for any number? What will be the starting position of p? Yes, correct. The starting position of p will be 2, because any number we will first check whether it is divisible by 2 or not. Okay, 1 we do not need to check. 1, it will be definitely be divisible, therefore in the string 1 is already present. Okay, so we will begin with 2. Fine. So this is my 3 variables that I am going to pass. Sorry, these are the 3 variables that I am going to pass. Fine. Now what should be the base condition? Where should we stop? Where should we print? Can you guys tell me what should be the base condition? Where we are printing? Where are we printing? When are we printing? No, we are not printing at that point. When are we printing our string? When are we printing 134? When are we printing 1322? No, we are printing as soon as this value becomes 1. Come on, think. We are printing as soon as this value becomes 1. Isn't it? The condition that of P1, that will be in a loop, but we are printing as soon as this value becomes 1. Once this value becomes 1, stop the recursion and return back. No need to move any further. Okay. So that will be a base condition. That is, if dash is equal, no, we do not need one more variable. I will explain that point. If dash equal to 1, print the string. Print the string. If this condition is true, we will print the string. Okay. Now, yes, correct. You're exactly correct. What will come here? Now just see, just just observe. It is 12, and we will begin with 2 because 1 is already in the string. And just think, what is this? This is nothing but n. What is this? This is nothing but p. Am I correct? This is n and this is p. Now this divide 2 divides this by 6. Okay. Now this is a function call that we have just made. This is a function call that we have just made, that p equals to 2 and n equals to 12. String is this. This is the function call. This, the first division that we made, this is a function call that we have just made. Okay. Now once we come out to 6, now here this is a different function call for our recursion. This is a completely different function call for our recursion, where n value is nothing but n divided by p. N value is nothing but n divided by p. And this will start with p. This will begin with p. Whatever the previous p value was, this will begin with p. Now, so for this recursion, what will pass? We will pass n by p in case of n. We will pass our p value, correct? We will also pass our string. We will also pass our string that now appends p. That is nothing but this 2. That is 2 is done. Now move forward with the next step. Let me explain you these points again. Okay, using a loop. Now see, what will happen after this? You have to start a loop. You have to start the for loop. For I equal to p, I will begin with p. Why I will begin? I am beginning I with p, not with 2. Why I am beginning I with p and not with 2? Yes, correct. I am beginning I with p because I have explained you this point, that we have to start with values that are equal to the previous division, not the smaller values. We cannot start with the smaller values. So you cannot start I equal to 2 every time. So this was the major issue that I found out within your codes. You cannot start I equals to 2 each and every time. Okay, you have to start with I equals to p to handle the repetition case. Fine. I less than equal to n and I plus plus. Simple. Less than equal to n means still 12. Fine. Now here, if my n mod I equal to 0, that means this divides this. That means we are here currently 12 and 2. N value is 12, I value is 2. N value is 12, I value is 2. Correct? N is 12, I is 2. N is 12, I is 2. Is it divisible? Yes, it is divisible. Since it is divisible, call the function again with what values? With values n divided by I. That means n divided by I, that is nothing but 6. Call the function again with n divided by I, which is nothing but 6. Okay. Then pass the current value of I. Why the current value of I? So that the next recursion call will begin with the same value, not with a smaller value, but with the same value. Okay. And append into your string this I. Now p represents I. Come on, think about it. Now when you write this down, you will write here int n, okay, int p, and your string. So where this I value will go? This I value will go to this variable. This I value, the second variable, will go to this variable, because now p equals to I. Is this understood? Why I'm passing I, not p? If you pass p is always 2. P will never increment. You have to increment p also. This variable is p. I will go to p. Not understood? Yes. Fine. I will pass to p, and p value will become equal to I in the next recursion call. We will see the next recursion call. Now append string. So 1 was there. You have to append simple I to it. So now the string will become 1 space 2 space blank. Okay. This now the new values, that is n by I is nothing but 6. I value is nothing but 2. So it will become a new p value. Okay. And new string will become 1 and space 2. Let's now write these points down. So here in the new recursion call, n will become n by I. What is n by I? It is nothing but 6. Okay. P will become the value passed before, that is nothing but 2, and string will be 1 and 2. Okay, with a space. Now do the same thing that we have did for this. The same thing. First it will check the base condition. Now what is the base condition? Base condition is if n equal to 1. Why? See, we are always passing n by I to n. So when dividing by dividing, at a time when it becomes equal to 1, you have to print the string. At time when it equals to 1, you have to print the string. Okay. So let's now move forward. Now this condition is not satisfied because n equals to 6. Now again start the loop. So for I equal to p, I less than equal to n, and I plus plus. Now what is the value of p? 2. So this will start with 2. Okay. If n mod I equal to 0. Let's now see. Now this I value, p value will become give to I, p value is 2. So here it will come 2. Can 2 divide 6? Yes, 2 can divide 6 by 3. Okay. So call the recursive call, since it can divide by n by I again, the same one. I append 1, 2, and again 2 because I value is 2 to this, and it's over. Okay. So now n by I is nothing but 3. So this is our new recursion call. This is our new recursion call. Okay. I value is again passed as 2. I value is again passed as 2. This value will go and store in the p value. This value will go and store in the p value. Okay. So in the next recursion call, here in the third recursion call that we are just seeing, n value will be n by I. N value was 6 here, I value was 2, I value was 2. So 6 divided by 2 will become 3. Okay. P value will become the I value that is passed. It is nothing but 2, and string will be 1, 2, and 2. Fine. So now the same process. Is n equal to 1? No, the base condition fails. Again start your for loop. Again start your for loop. For what I equals to p, I less than equal to n, I plus plus. And here if n divided by I equal to 0, sorry, not divide, mod I equal to 0, call it again, else do nothing. So now I value is equal to 2, I value equals to 2, n value equals to 3. So we are here. Okay. So can 2 divide 3? No, in this case 2 cannot divide 3. So nothing will happen. I value will be incremented to 3 now. I value will be incremented to 3. Okay. So nothing happens. I value is incremented to 3. Can 3 divide by 3? Yes, 3 can divide 3 to 1. So in that case, because now n value is 3, I value is also 3. It can divide. So call the function again with n by I, same values I, and in the string just append the current I value because it can divide it 1, 2, 2, 3. Okay. The same process will again repeat. Now n value will be n by I. What is n by I? N by I is 3 by 3, that is nothing but 1. P value is the current I value. I value is nothing but 3, which is passed, and it is string is 1, 2, 2, 3. Now the base condition satisfies that n equal to 1. So print 1, 2, 2, 3 and return back. So now we have a one of our string printed as 1, 2, 2, 3. Okay. Now once a recursion is called, it is printed 1, 2, 2, 3. It will come back. So the stack will become empty. Okay. Now what will happen? This loop will run again. I value will become 4. Now 4, can 3 divided by 4, because n value is unchanged. Can 3 be divided by 4? No. So this will run all the time till I value will become 12, and this loop is over for I equals 13, and you will return back. Is this clear, or I have done some mistake here? Come on, think about it, what I just told you. So now it was 112, then it become 212, and here it is 6. Okay, we have 2, we have 3, we have 1. So we printed this one. Now it returned back here. Now it will change to 4, it will change to 5, it will change to 6, it will change to 7 till 12. Okay, nothing will happen. Now this will be over, this call will be over, and it will be returned back to the function which it called from. So it was called from this function, so it will return back here. Okay, that means it will return back here. Fine, is this point understood? So that means this will be over now. The whole stack will become empty. Recursion stack, this part. Okay, fine. Now what will happen? Now here n value was 6, as you can see, n value was 6. I value 2, everything is over. I will increment, I value will become 3. Now that means this part is over for this. These whole things are over. And we are here back, and now this becomes 3. This becomes 3. See, the same steps that I have explained are following right now. Now 3 can divide 6 by 2. 3 can divide 6 by 2. Okay. 3 divides 6 by 2. Nothing, no problem, no issue with us. So 3 divides 6 by 2. So what will be the new n value? New n value will be 2, because n by I, n value is 6, I value is 3, n by I is 2. I value will become 3, and it will be 1, 2, and this will be changed to 3 now, 1, 2, 3. Now, since this value is changed, can you guys tell me what will happen? It is very simple. No condition will be satisfied, because I value start with p, and p value here is 3, and n value is 2. So n mod I will never satisfy, because n value is actually smaller than this value, I value, every time. N value is 2, and I value is beginning with 3, and it will go till 12. So it will never satisfy this condition. Okay, nothing will happen, and it will simply return back. See, this handled the repetition case. This handled the repetition case because nothing will be printed ever, because n value is smaller than its divisor. N value is smaller than its divisor for all the for loop, because it is actually beginning with a larger value. So this handled that case, that is the repetition case of this. We will not print the repetition. We will not print the repetition part. Okay. So now n value is currently 6, so I will become 4, nothing will happen. I will become 5, nothing will happen. I will become 6, and 6 can divide 6. When 6 divides 6, n value, new n value will become 1. As soon as new n value become 1, the base condition will be satisfied, and 1 to 6 will be printed. This here. Okay, 1 to 6 will be printed, because now n value is base condition is satisfied. So we printed 1 to 2 6, and we printed 1 to 2 6 and 1 to 6. These two are printed. Okay, so I've explained you the recursion. After this, now this is what I just did, is known as the recursion stack. Is known as recursion stack. I think you guys know that this is known as the recursion stack. This is how we trace the recursion. This is how we trace the recursion step by step. What is happening in our code? What is the value of our each and every variable at each and every recursion call? Okay, you have to give the number of the recursion calls also. This was the first recursion call. This was the second recursion call. We have seen the third, fourth, fifth, sixth recursion calls. Okay, why? Because after the second recursion call is over, you have to move back to the first recursion call. Okay, this was the recursion stack, and this is what we say to you to draw for each and every recursion question, because this will tell you where you are making a mistake. This will tell you where you can improve. The recursion stack is really important. Okay, especially in the beginning. So this, now I will implement it. I have already implemented it actually, but I will implement it in an IDE also. Okay, let me just start it. So I'll implement it in an IDE also. So let's just revise what has actually happened till now. So in the factors question, first point was you have to do it in a lexicographical order. Second we seen was there was no repetitions allowed. There was no repetitions allowed. Okay. Using the normal approach that we do for factors, that is 1 divided by 12, 2 divided by 6, this was solved. That is, we will find the factors quite easily just by dividing n by I. Okay, just by dividing, that is n by I. Most of you have actually got this in your codes. I have seen that you are passing n by I. Okay, you got this point that you have to pass n by I. Fine. Now, once you pass n by I here, okay, now the problem was, how do you stop the repetition? How do you stop the repetition? Now that repetition part is handled by using a simple condition that we have a value, you cannot go below that value again. Okay, once we have a value, you cannot go below that value again. When we have that condition, and that condition is perfectly valid. The reason being, a into b equals to b into a. Now if a case is handled in this part, why do I have to handle the same case again? Why do I have to handle the same case again? If a is smaller than b and a case is handled in the first part, why do I have to handle the same case again in the second part? You do not have to do that. To stop that, we are using a variable p. To stop that, we are using a variable p in our code. Fine. So after doing this, what can we do next? It's over. We just have to implement it what I have just written. Okay. Now I can implement it in C++ also. I can implement it in Java also. Okay. 1 second. I think you guys can implement it now actually, because nothing is left in this. Yes, yes, I will increase it. So what do we need? Scanner sc equals to new scanner system.in. I will not completely implement, obviously. I will just one point I will escape. Okay, scanner sc equals to new scanner system.in. Then after that, int t for the test case. I think, is the test case required in the question? Yes, it is. So int t equals to sc.nextInt. Then I will implement it in C++ also if you like. So t minus minus is greater than 0. After this, int n equals to sc.nextInt, and just simply have another variable in p which will begin with 2, and a string str which will have 1 in the beginning and a space. Okay, and pass this into a function. Now just have anything solve, pass your n, pass your p, and pass your string. Okay, your n, p, and string is here. After this, have a base condition. If n equal to 1, system.out.println, just print it out your string. Else, you do not, just you can simply return it or put else here. Now else, have a for loop for int I equal to 0, I less than equal to n, and I plus plus, and I plus plus. If n mod I equal to 0, simply solve. Now what we will pass? We will pass n by I, we will pass I, and we will pass something here. Correct? We will pass the string after appending the string to the value of I. Okay? Now, as you can see, I value will become here p value. Okay? I value what will pass will become here p value. Now you have to append here. Now this is the fill in the blanks. Just think how you will append. It is very simple. Okay? Okay, yes. Here it will be I value equal to p. Fine. Now you just have to append it. This part is remaining for you. Rest, everything is done. Okay. Now if we go to C++, what within the same thing in T. You can try anything you like, that is on you now. I have explained you the important parts. C in T, just try it and submit it. Let's see if you can. While T minus minus, and the same thing I'm repeating. Int n, C in n, and solve. Here n pass 2 and pass a string. Now void solve int n, int p, string str, and the same thing now. If n equal to 1, C out str, and what you can say handle. Fine. Else for I equal to p, int I equal to p. Now what I want you guys to do is trace it down on your own, pen and paper. Use pen and paper to trace the recursion calls. For the questions that you have completed, also you have to do this part, okay? Because this is an important step. This is very important, and do not take recursion lightly. Trees, greedy algorithms, dynamic programming, segment trees, and there are many things that are just mainly concentrated on recursion topic. The basic of those topics is recursion, okay? So you cannot just forget this topic. Fine. In the future, this is very, very important, recursion topic. Merge sort uses recursion, quick sort uses, no, sorry, merge sort uses recursion, heap sort uses recursion. So there is many things that uses recursion internally, okay? So just don't do anything. Oh, sorry. You have to implement this part on your own. This is the fill in the blanks. So implement this part on your own, okay? So this is in C, C++, and Java. I don't think there is anyone here who code in C. Fine. So ask me anything now for what you are facing difficulties in recursion topic. I'll show you implementation also this time. If you ask that how, if you ask this point, okay, if you ask this point that actually how we have this, how we know how many variables we need to use in different questions, or how do we know which variables to use, then actually that is question dependent. Okay, that is not a general question, it is question dependent. In this we need variable n. For example, you are drawing a recursion tree, okay? Then in that recursion tree, at each step you are adding something to your string, fine, and you want to stop when that string length equal to n, okay? So you can use an index for using the string length, that when index if become equal to n, then stop, then print. Then we need an index variable in that case, okay, that will keep track of how many elements have actually been appended or added into the string. And as soon as it becomes equal to 3, then it's done. So these are the steps only. So the first step is identify the just try to draw a recursion tree, okay? Second, identify the base condition where we will stop, print and return. Third, you need to identify all the variables that you will be using. Fourth, recursion tree, identify the base conditions, the variables, that's what you need. Okay, if when you are done with this, okay, and you started without writing the code, just think that how that recursion will work on a paper, that is user recursion stack. Without writing the code, just think how that recursion will work. Do I need another recursion call in this program? I need that if I come back and if I have to go to the right, I need another recursion call, or will this recursion call be enough for me, the single recursion call? Because in some questions you need two recursion calls, in some questions you need a single recursion call, in some we need three recursion calls, okay, in different if else conditions. Fine. So you have to think about it, and it will come with practice only and nothing else. Okay. So once you are done with this part, that is, you have understood what the question is saying, you have understood that it will seem difficult in the first half, but if you have understood what the question is saying, okay, first try to draw a tree. You have to draw a tree for a recursion. Once you draw a tree, it will become actually really, really simple to understand once you draw a tree, because then what you have to do, you know that you have to come, when you have to come back, what is the base condition, what are the different in variables do I need to use for that part. It is really important to draw a tree, or what the thing that I have drawn just here, it is a type of tree only. Okay, using that only, the thing that I have drawn here, 12 1 12 2 6, these things, I knew what was my base condition. As soon as it becomes one, that was my base condition. I have to return back. Once I have to return back, and that repetition case we have to handle. So how we can handle that repetition case? Okay, this only showed me how to handle that repetition case. Nothing else showed me. This only told me that I have handled 2 into 3 equals to 6, that case previously. So why I have to handle it again right now? So to stop that, I will just begin with the same proceeding again. So for that, I need another variable p. So I added that variable into our program. Fine. So step by step, you will get these points. Step by step, solving the questions one by one, you will become comfortable in recursion. And the most important point, which I felt when I was learning and practicing recursion, was the recursion stack. Yes, I know it is a very big process to draw the whole recursion stack. Okay, but in the beginning, I urge you that I recommend you to draw a recursion stack for the questions that you have already done. If you have done this question of pattern printing, the first 2 or 3 questions, or GCD, the first 2 or 3 questions, correct, that you have to print 16 11, then 6, then 5, sorry, 1 minus 4. So you have write the you may have written the code for this. So once you have written the code for this, then for this also, after writing the code, just see how the recursion is actually working. What is the inside working of the recursion? Once you know the inside working of the recursion, you will be confident in it. You will be confident in it. Okay. Here also you have seen that just after doing this one part, just after writing this and writing the recursion call for just 3 or 4 recursion stacks, I just drawn 4 to 5 recursion stack. I haven't moved forward. I knew it will work. I knew it will work after just 3 or 4 recursion stacks. So after practice, it will not take so much time. After 3 or 4 recursion stack, you will know, oh, this will work definitely, or the tree will work. But in the beginning, for these questions also, for the simple questions also, draw a recursion stack. For factorial using recursion, for Fibonacci using recursion, these are simple questions. Okay, draw a recursion stack for each and every one to understand. Oh yes, this is how the recursion call works. This is what it will return. This is how I can keep track for all the variables in my recursion. Okay, so you have to think of all these points very deeply, because this is an important topic. The whole tree topic is based on recursion. Okay, there you will have a tree. Here you draw a conceptual tree, there you will have an actual tree. The recursion will work. It will go back here, it will come here, it will go back here to a left tree, to a right subtree. Everything will happen in with the help of recursion only. Dynamic programming, greedy, backtracking, heap, segment trees, these all things are dependent on recursion topic only. Okay, and many more. So do not wait, do not think, give time to this topic. This is an important topic. Okay, recursion is really, really important in competitive programming also, and in interviews also. Fine. So just keep thinking on it. So if you have taken an array, then you have to actually use one more variable to keep the track of how many elements you have stored in that array. And you have to use a for loop to print that array also. That would have increased the complexity. correct? One more variable will be needed to keep the index. That is, you have to handle the index also in that case. But while using string, you do not have to handle the index. You can do it with array also, but I don't think it will pass. It may pass. You can try. Okay. Okay. Let's see the time complexity. N by I every time. Correct. It will run for n time and it will be n by I each and every time. So what is the time complexity? N by I is nothing but log I. When we divide by I, or when we multiply by I, so it is nothing but logarithmic time. Okay, and a for loop that will run for in the worst case till 2 to n, that is nothing but n times. Yes, but here we have to actually write a recursive equation and solve it down. Okay, so it is nothing but for each n, for each I, it may run for n by I times. So yes, it will be n log n only. Correct. Finally, it will be this only. Okay, so it will definitely pass in 1 second. Fine. Okay. So good night. Take care. Thank you. Good night.